Hello, this is mixed exercise 10 taken from the Year 1 Edexcel Pearson textbook, question 15D. So at this point, I suggest you pause it, read the question thoroughly, and then press play when you have understood what the question is asking, and we'll go through it. Okay, first of all, a diagram. I know you're given one, but I would still be drawing a diagram out. So here is my pulley. I'm going to just push that up a bit, and I have these hanging down. These are the masses at the bottom, and my masses are P and Q. I have a tension acting up for both of them. Remember, tension would be also acting in that direction. And actually, when we're dealing with connected particles, we also almost have this imaginary, it's quite often used, dotted line, so that when we're dealing with P and Q, we can imagine what's going on below that dotted line for P and Q when we're resolving for forces. And it can help some students. It might help you to see that. We've also, remember, got our masses which are acting down. I just need to scroll up to check on those. So P is 0.5 and Q is 0.4 G. The next thing I need to look at is direction of motion. It is release from rest. That's in the question. So if you hadn't realised that, just have another look. It says about it being released from rest there. So what we need to do is mark on the direction it will go, and because P is the heavier mass, that is my direction of motion. It's important to put that on and also to mark it on both sides before you start, so it will help you with resolving. So that's your diagram, and now we can start looking at answering part A. So looking at part A, write down the motion of P. So part A, when I'm looking at writing down the motion of that, so this is for P, remember, and remember which way is positive. It's acting down is positive, so I'm resolving, and the reason it is positive is because that's the direction of motion. Resolve in the direction of motion and take that as positive. So therefore I'm going to write 0.5 G, subtract T, because tension is acting against motion, and that would equal my mass, which is 0.5, times my acceleration. Part 2 asks me to repeat the same process for Q. So which way am I resolving? So I look at my direction of motion. Direction of motion is upward. So now tension's positive and my weight acting down is going to be negative. So I'm going to write T subtract 0.4 G equals 0.4A. So that's part A now done. I've resolved for both particles separately. Right, so now I'm looking at part B. It asked me to find the tension in the string. Now you notice the question first of all asked me to find the tension in the string and then see the acceleration. I'm actually going to choose to find the acceleration first. This next stage is simultaneous equations, and I need to eliminate a T, and then, well actually if I'm going to find tension I'm going to need to eliminate A. But to eliminate A, I'm going to have to multiply this one by 4 and this one by 5, and it would be just easier, I feel, if I just added them together because tension would be eliminated. However, that does mean I'm going to find acceleration first, which isn't exactly what the examiner asked for. But he won't mind that you've done that. For me, I feel it's an easier route. So for part B, I'm going to add those together. So I'd end up with 0.5g minus 0.4g, because when I add a negative number, it's the same as subtracting. And that would be 0.5a, add 0.4a. So I end up with 0.1g equals 0.9a. So then dividing by 0.9, I'd end up with a equals g over 9. You'll notice I've put g over 9. It's because I just prefer to work with g and put 9.8 in at the end. You can put 9.8 and then divide it by 9. There's nothing particularly wrong with that. But it does come out as recurring decimals. So at this stage here, if I leave it like that, I'm going to be using an exact value. So remember, that's not what actual acceleration is, tension is, because that's what I want to find. So I do have to substitute it back in. So you could say that it's easier not to, but I have chosen this route, so I'm going with it. So it's 0.4. I'm substituting it into my equation, by the way, for Q I've chosen, only because T is positive in that one. So 0.4 times G. Let's just rub that bit out. Times G over 9. And that would be subtract 0.4G. So if you're wondering where I've just got that from, it's here. Okay, so I've just got that bit there from there. So T equals 0.4a, which is that bit there. Oh, it should be a plus. Do you see I've made that slip there? Let me put a plus there. That's a plus. So let's go, just let me point you back to that. That's what I'm using. So T equals 0.58, add 0.4g. So this then is just typing it in your calculator and using your value for g you type in as 9.8. So my answer for the tension is 4.35 newtons, and that's just by typing it in. Okay, so that's part B complete. Now you've already did part C in the last bit, so therefore you can just then say that C A equals G over 9 from before. And G over 9, if you type it into your calculator, would come out as 1.09 meters per second squared. And that's that. So we've now got our tension, and we've also got our acceleration. So let's go back up now and look at the next stage, what we need to do. So find the further time that elapses until Q. Oh, I haven't read all the question there. So let's point to it all. When the particles have been moving for 0.2 seconds, the string breaks. So it's going to move. Let's think about what's happening here. I'm going to go over to here for D. So what's going to happen first of all for the 0.2 seconds? So for T equals 0.2, I know that U was equal to 0. I know my acceleration, because I've just worked that out. I'm not going to use 1.09. 1.09 was rounded and it's inaccurate. So I'm going to go back and use G over 9. Okay. And the question's asking me, find the further time until Q hits the floor. So they're all the things that I know, but actually that's for 0.2. Now, what I'm looking at is Q hitting the floor. So what I need to understand is what's actually happening to Q in this motion. So we know that Q is moving upwards. So what's happening to Q is it's accelerating upwards for 0.2 seconds. And it will get to a point, possibly here, I'm not too sure where, and it will be travelling at a speed because it was at rest, and it's accelerated upwards and it will have reached a speed here. And then it will also have travelled a distance upwards, okay? And then what is going to happen is the string snaps. Now at that point, it's not a connected particle anymore, and it's actually going to, its acceleration is due to gravity. So we've got to look at what is going to travel upwards a certain distance, it's going to be travelling at a certain speed, and then the string is going to snap. So what I'm going to do, let me draw a little diagram over here. I'll draw it in a different pen. So here's our pulley, here is P, here is Q up here, and this here, if I go back, I'm just going to pull back a moment. Remember this 2 meters here that it was above. So P would be now below that 2 meter line and Q above it. So if I go here, I've got this 2 meter line across here. And we can say that this distance here to the floor, this is 2 meters. And then Q is a distance or a displacement upwards from there. So shall we call this S for the displacement? So when the string breaks, the total distance that Q is going to fall is going to be that small displacement and the 2 meters. And if we think about it, at this point, when the string breaks, let's just get my pen, so string breaks, I don't know what u is, but u would be the same as the velocity for here. So the velocity here would be the same as the value of u here, because the velocity here, this is what it's moving up at. It's moving upwards than this point here. Let's write up here so that you realise what this is doing. So here it moves upwards. The string breaks at this velocity. At that moment when the string breaks, that's the initial velocity, and we've got to think that that's the initial velocity for when the string breaks. Now, our acceleration for this, if we're saying that this velocity is moving upwards, we've got to realise that this acceleration is due to gravity. Now for this question, I spoke earlier about deciding which direction we're resolving in. It doesn't matter. It doesn't matter whether you choose upward to be positive or downwards to be positive, but you must stay consistent, okay? So here, if you're going to take this velocity as positive, this velocity was moving upwards. And if you're going to take that velocity as positive, then you must, in this question, this part of the question here, then this acceleration is acting downwards because acceleration due to gravity is downwards. So this here would have to be negative. So before you start doing the question and start putting the numbers in, because this is where you're going to go wrong, you've got to decide which direction you're going to make positive. Are you going to make positive going upwards, or are you going to make positive going downwards? And the choice is yours. Now, I'm going to choose, because the gravity is acting downwards, to make that positive, and I'm going to make this G. Now, the distance that my particle Q has got to fall is this S plus this 2 meters. So for this here, my total displacement will now be 2 add S. Oh, sorry for that line that's just appeared. Let's erase some of that. Now, the thing we want to find, if you remember, is T. So what I need to find is, going back to this stage here, is V from here. So to find V for this here, I'm going to use V equals U plus AT. So that's 9/45. Notice the accuracy I'm working to, because if I don't keep that accurate, you start getting rounding errors coming in. So displacement, I also need to work out S, the distance it's moved up, if you remember. So this is this distance it's moved up since it was released. I can do that using this. So I also need to find my S. I don't want to use V here, so I'm going to use S equals UT plus half AT squared. Sorry, I wrote that the wrong way round, you could say, because I actually wrote T there and A there, so it's AT squared. So again, typing that into our calculator, and that gives me that S equals 450. Sorry, I've written that the wrong way round, G over 450. So just recapping, I know I'm going back over this, but I just want to check you're there with me. This here is the velocity that Q is moving up with. At the point where it breaks, that's the velocity it's moving upwards with. And this displacement here is the displacement since it was released to the point where it breaks. And I found that using this information. Now I'm going to take this and use it over here. But I need to be careful, as I've said, of that direction thing. So coming back over to here, U. Well, U is now the velocity from the last part. Remember, that velocity was going upwards. I'm now taking my direction as down, being positive. So therefore, this has to go in as negative 9. Oh, sorry, G over 45. So I need to be very careful with that to make sure I get that right. And here, my displacement, well, my total displacement is the displacement here plus my 2 meters. So if I put that in, it would be 2 add G over 450. So what I'm needing to find is my time. I don't disagree, this is going to be really quite messy numbers, because you can see we're going to have to use S equals UT plus half AT squared. So I would write 2 add 9 over 450 equals UT plus half A, which is going to be G, T squared. Now, you may not realise it, but you do have a quadratic here. And you do need to do a bit of tidying up with, and now you're going to actually have to accept putting the values in for G. So I'm going to just pause here, tidy it up and rewrite it down, and then we can go to solving it. Okay, so I've tidied it up a little bit. Use the fractions button on my calculator. It so helps you if you type it in. The calculator gives you some easy fraction numbers. It'll even put the first part into a fraction, but I'm quite happy with 4.9. The others, I didn't go for them because they're reoccurring. What do I do now? This is where you're going to need to use the quadratic formula. So you then need to put this into the quadratic formula, or minus b plus or minus the square root of b squared minus 4ac all over 2a. You need to show that workings, but remember, A-level calculators now have the function where you can also solve the quadratics. You need to write your workings down for using the quadratic formula, but do use that function on your calculator to get the roots as well, to check them. So off you go, press pause, get the two results out. This is just you practicing some of those core maths skills that are coming into mechanics. And then press play when you've got them. Okay, I'm hoping you've managed to get those results out now. So you should have ended up with T equals 0.665 or T equals negative 0.621. Well, you cannot have negative time. We can't go backwards. So it is only the positive root that is relevant here. So because this is not possible. So therefore, Q hits the floor. Because let's just go back to the question so you remember what all this was all about. As we can forget. It says find the further time elapses until Q hits the floor. So here we go. Q hits the floor. If you're doing it to two significant figures, it would be 0.66. Be careful because that was rounded. 0.66 seconds after the string breaks. And there we go. That last stage is quite a lot of thought has to go into that, and you need to break it up into the stages, what happens before the string breaks and what happens after the string breaks. You also need to think about the direction of motion before the string breaks, the direction of motion after the string breaks, as in initially which direction are you going to take when you're resolving as positive, because if you don't get that right, then your calculations will then go wrong.